Good morning. I want to talk about the development and future of commercial production of wildlife in South Africa. I wish to thank the Grassland Society of Southern Africa for the invitation to present some ideas. Nikki de Tooy of Gouris Clustered Biosphere Reserve, who made the version possible, and all you delegates for listening to me. This was the status of wildlife in South Africa before 1991. The Game Theft Act of 105 of 1991 changed the legal status of wildlife to private property. Several early crucial mistakes were made in developing wildlife ranches in South Africa. The consequence was continued habitat destruction and bush encroachment. Other negatives were that wildlife-proof fencing stopped natural gene flow, short-term financial gain overrode sound ecological management, and that excessive focus was placed on high-end markets such as luxury tourist lodges and foreign trophy hunters. Some statistics of wildlife ranching in South Africa include the following. There are around 15,000 wildlife ranches, of which 81% are in subtropical Limpopo, Northwest and Northern Cape. The mean size per ranch is 4,744 hectares, and the total surface area is 5,692 square kilometers. The live wildlife auction data are the main index for the wildlife industry's economic statistics. The problem is that official live wildlife auctions only represent an estimated 25% of all live wildlife being traded. The live wildlife trade mainly happens in the Limpopo province. This slide shows the trend in the live wildlife trade from 1991 to 2019. It is clear that phase one was from 1991 to 1995, when the game ranches were being restocked with wildlife, with plains wildlife mainly. Phase two from 1996 to 2009 was the investment in rare wildlife such as the roan antelope, sable antelope, and disease-free buffalo. It peaked in 2004. Phase three was from 2010 to 2020 and involved investment in exotic wildlife such as the East African buffalo, Zambian sable antelope, and color variants such as the golden and king blue wildebeest, black impala, and golden gemsbok. The current phase is stabilization and investment in indigenous, genetically pure animals and stud breeding of wildlife. This table shows the value loss in rand in phase 3 for selected game species. This graph shows that the main sources of income for properties independent of size were recreational and meat hunting and the breeding of animals for live wildlife animal trade. Sustainable hunting provides 77% of the income of the wildlife ranches, and the income from recreational and meat hunting is more than 50% of the income generated by hunting. Namibian rural conservancies use tourism and hunting to provide a sustainable economic development. Several factors impact on wildlife and habitat conservation. This slide shows that climate cycles and habitat changes are linked to continental drifting and that mass extinctions have occurred in cool and warm cycles. Climate change has occurred throughout the life of the Earth. It is more than just carbon dioxide levels in the atmosphere, and it is enshrouded in myths and disputes. This slide shows how the main gases in the atmosphere changed with time. Carbon dioxide in the atmosphere is a cornerstone of life on Earth. If the carbon dioxide is depleted in the atmosphere, the Earth will enter a permanent ice age, and carbon dioxide participates in but is not the main driver of climate change. Carbon dioxide levels in the atmosphere have been increasing before the Industrial Revolution, but global temperatures and carbon dioxide levels have increased sharply after the Industrial Revolution. The main drivers of global temperatures are the eccentricity cycle of the orbit of the Earth around the Sun, the tilt cycle of the axis of the Earth, and the wobble cycle of the axis of the Earth. This slide shows that the orbit of the Earth varies between almost a circle to slightly elliptical in a cycle of 100,000 years. The Earth's orbit varies from slightly elliptical to nearly circular in a cycle of 100,000 years, as just said. The Earth's surface receives 20 to 30% more solar energy when its orbit is totally circular than when it is totally elliptical. The current eccentricity is almost circular. The eccentricity during the last ice age was almost elliptical. The axis of the Earth wobbles in a cycle of 26,000 years. The wobble changes the direction in the sky to which the axis points, and when the axis points directly at the sun, the global temperature is the highest. The Sahara Desert and the Arabian Desert are both linked to the uh, Tethys Sea, which once separated Laurasia and Gondwana from the equator to 30 degrees north and stretched from the Himalayas to the Caribbean. The sands of the Saharan Desert and Arabian deserts were deposited on the northern shores of Gondwana by the Tethys Sea. When drifting elements of Gondwana collided with Eurasia some 50 million years ago, it closed off the Tethys Sea and left the Mediterranean Sea as an ever-dwindling remnant. The wobble of the axis of the Earth causes significant shifts in the solar radiation and monsoon in North Africa. The Sahara region varies from a desert to a savanna grassland in a cycle of 26,000 years. The Sahara region was last wet 14,800 to 4,500 years ago, and the next predicted wet cycle is around 15,000 years from now. Other drivers of the global temperature are oceanic thermal vents, where tectonic plates drift apart, changes in the oceanic currents due to drifting continents, human population increase, especially the stripping and invading of forests, and volcanic ash clouds which block the sun. This is an example of a volcanic ash cloud blocking the sun. There have been 75 major temperature swings in the past 4,500 years on Earth. 2,260 of the last 11,300 years were hotter than now. The current mean temperature is equal to what it was 7,000 years ago, and there has been more than 100 major volcanic eruptions in the current temperature increase phase. Gondwana was once covered in rainforests, of which some remnants still occur in Australia. Plastic pollution is a major problem in the environmental conservation as it disrupts the functioning of ecosystems. This slide is an example of plastic pollution on a tropical beach. Enclosed areas often become fragmented ecosystems which then require management intervention. This slide shows the consequence of an extreme habitat degradation as a result of enclosed areas. The major management intervention required involves rehabilitation of soil and vegetation to create functional ecosystems. Enclosed areas have real or virtual barriers to animal dispersion. Natural mortalities do not keep animal population growth in check, and excess animals have to be harvested to prevent habitat destruction and deaths due to hunger and thirst. Metapopulation genetic management is also required. The Tsavo East National Park is a prime example of the problem. It has a surface area of 13,747 square kilometers, and there were 35,000 elephants before a 3-year drought started in 1970, and 6,000 to 9,000 elephants died from starvation and thirst. The habitat was changed from an open savanna to a degraded grassland. Destruction of the habitat, food and water sources caused the death of thousands of other wildlife, including 2,000 black rhinoceroses. Another drought in 2009 caused the death of 40% of the other wildlife from starvation and thirst. This slide is an example of how the habitat can be destroyed by an overpopulation of elephants. The question is, how long does an elephant take to die of hunger or thirst? The answer is 3 months. The destruction and invasion of natural habitats by humans are serious conservation threats. Conservation and poverty are related because it is impossible to preach conservation and anti-hunting ethics to a hungry person. There is no way in which you can preach conservation to poor people in rural Africa. Limited space also destroys natural habitats. What then is the future role of commercial wildlife production? It can provide food security, promote conservation, and create sustainable economic development. It will require the wise use and management of wildlife. As Africa experiences constant drought-induced famines in arid regions, And the wise management of wildlife requires a population control to prevent habitat degradation and periodic die-offs from hunger and thirst. The sustainable use of excess wildlife is a powerful tool to provide food security, promote conservation, and create sustainable economic development. Southern Africa has 65 and Africa has 219 large angular species, of which are better adapted to survive global climate changes than most livestock. These ungulates have a wider dietary scope than domestic livestock, and passive wildlife capture techniques and mobile abattoirs make it possible to harvest excess wildlife in remote regions. What then should be done with the wildlife industry? It should focus on breeding rare wildlife, should focus on breeding good quality wildlife for hunting. It should focus on mixed wildlife livestock production and the harvesting of wildlife for food security. Other requirements are to invest in habitat rehabilitation and management, manage the wildlife on enclosed areas genetically as metapopulations, and to develop a reliable database on all aspects of the wildlife industry. The development of conservancies in rural communities should be encouraged. All commercial wildlife producers should be registered, and all wildlife producers should be graded based on the ecological and an economic approach. The major objective is to maintain well-managed savannas and grasslands. In a nutshell, limited space and the dwindling of renewable natural resources drive land degradation and create famine due to a rapidly growing human population. Commercial production and wise use of wildlife can be a major conservation and economic development tool and ensure food security for millions of people. Habitat management is a crucial element of wildlife management. The ultimate objective is an optimal ecological and economic balance. Thank you for listening.
Good day, my name is Ken Kutsia, and I want to talk to you about practicing effective habitat conservation on commercial game ranches in South Africa, but with some examples from Africa as well. There are many examples of overgrazed and damaged farmland in the Eastern Cape, and as well as rangelands invaded by alien cactus species such as in Laikipia in Kenya. Typical examples of savanna destroyed by shifting agriculture in Nigeria, and also severe gully erosion on farmland in the Little Karoo. This is a good example of very poor farming practice in the Karoo in South Africa, with speckboom thicket that has been completely browsed out by small livestock farming. As you can see on the left is dense thicket, on the right the thicket has all but been completely removed. With the loss of plant cover, one has a loss of topsoil and also a loss of soil organisms. The loss of topsoil and of soil organisms results in a general aridification of the rangeland. With our work in environmental conservation and the management of private game ranches, we have been successful at numerous localities in restoring natural veld, bringing back drainages where formerly there were just erosion systems, and also creating useful grazing where there was overgrazing by livestock in the past before the areas were established as game ranches. These are examples mostly from the area of the Northern Karoo and the Little Karoo. A practical approach to the restoration on game ranches involves a number of steps. The first one is to remove the cause of the degradation. In most cases, it would have been overgrazing in the past with livestock. The second step is then to establish a restoration management plan, which consists of three parts: soil stabilization and monitoring, vegetation improvement and monitoring, and wildlife management and monitoring. This is just an example of one of our management plans showing the list of actions relating to the soil erosion control program. And as you can see, the actions are all prioritized and built into the management cycle In other words, the landowner then knows exactly what to do and when he should do it in his 5-year management planning cycle. Preventing aridification. There are a number of requirements. The first is to slow down rainwater runoff. The second is to improve rainwater infiltration. And the third is to improve the plant cover. Here is a typical example of gully erosion on a game ranch in an area that was previously and historically overgrazed with small livestock. As you can see, the gully ends just beyond the person standing in the picture, and that is what we call a gully head cut. And this is the area that we would then attempt to arrest soil erosion to prevent it from eating back further into useful soil. The method that we use to deal with steep-sided gullies is to reshape the gully so that there is a much more gradual slope on which plants can more easily establish. Here is another example of a very steep-sided gully system that has been reshaped and flattened out so that one can more easily establish a plant cover which can then protect the soil from being washed away. After the area has been shaped, the entire shaped area is covered with an organic geotextile called soil saver, which is spread over the area and then pegged to the ground using wooden pegs. Once that has been done, the entire area is then brush packed with either a material that can be cut locally or a material that is brought in from outside if nothing is available locally. Here is another example of a steep-sided gully, and the fellow in the gully is a very tall man, so one can see the amount of exposed soil which dries out under the hot Karoo sun. And this area was chosen for rehabilitation also by using the reshaping method. The same area as the previous slide, showing the area once it has been covered with geotextile, and in this case it was entirely covered with wood chips which were available from relatively close by sawmill, and this only a few months after the area was shaped to create a more gentle slope for plant establishment. Here we have an example of the use of local materials, and in this case brush checks were made to slow down runoff water using alien plant material cut out from a riverbed in the Little Karoo, and the students are busy cutting up acacia, or rather thorn tree branches, to fill in the small gullies to trap waterborne silt and organic material. Here we have a bare-capped area due to past overgrazing, trampling, and rainwater impact as a result of it being completely exposed to the elements. Runoff water is completely lost from the site every time it rains. We deal with these capped areas, sheet eroded areas, by digging hollows in the ground. Each hollow holds roughly 45 to 50 liters of water, and the way that this helps is that each of these hollows fills up during rainfall, and the cumulative amount of water in say a couple of hundred or thousand hollows dug by hand rehydrates the soil, and each of these hollows can also then collect a little bit of wind-blown plant material and seeds, and becomes a safe haven for germination. After the first rains, the hollows will fill up, and as you can see, some plant litter is trapped in some of the hollows, and a little bit of silt as well. And already after a couple of rainfall events, one can see some pioneer plants starting to take root, and As time goes by, these plants will spread over this area from hollow to hollow, in between the hollows, creating the kind of protective cover that one needs to prevent further soil erosion off the site. This is a site in which hollows were made across the bare-capped area, and showing that wind-blown seeds of grasses were trapped in the hollows, and these grasses also help to retain moisture in the soil after rainfall events. The entire area was also covered with thorn tree branches to keep grazing animals away from the growing grasses and to give them a chance to mature and to produce seeds for further plant establishment. Here, this slide illustrates the use of two different types of geotextile. The one flat on the ground is the soil saver, which is an organic jute material, which we use to cover shaped areas. And then the other vertical material and buried in the ground is called grass fence. It is a plastic woven material that is UV resistant, and this is used to prevent runoff water from damaging the erosion control structure. The, the, the use of the vertical soil erosion fence is basically to slow down the speed of water and also to trap waterborne silt and plant material and other organic material like animal droppings and so forth. Here we illustrate that one can make use of any organic material to help prevent further soil erosion and also to cover bare soil. In this case, we are making use of agave leaves in an area where a couple of hundred agave plants had to be removed. And we use the leaves behind one of our soil erosion control fences to slow down water, trap silt and animal droppings, and also the seeds of grasses and karoo bushes carried by the water. This slide illustrates the use of agave leaves to cover bare areas. As you can see, there is quite a good regeneration of both karoo shrubs and grasses, which germinate under the protection of these leaves and in a soil which is um, kept moist by the cover of the agave leaves. Here one can see the result after only one good rain season in the same area, showing the abundant growth of grasses in the former gully area that was stabilized using little erosion control fences and the packing of agave leaves over the surface to slow down the runoff and to protect germinating seeds. Part of our work on game ranches is also the control of the spread of invasive alien plants. Severe cactus invasions such as this one in Kenya, consisting of two different cactus species, is quite devastating in the amount or the total area that is covered by the cactus plants. There are areas here where cattle can't even walk through the area, let alone graze. We advocate the use of biocontrol for the control of invasive alien cactuses, and this can be very easily done by setting up a simple to build nursery in which the biocontrol can be grown in buckets by just reinfesting new leaves continuously and then planting out these leaves into the cactus infestation so that the biocontrol agents can spread onto new plants. So this is an action that must be continuous in order for the biocontrol to have a useful effect. Here we have the torch cactus, which is highly invasive in most of the Eastern Cape and a very big growing problem that is relatively unattended to. The problem with this torch cactus is that there is currently no biocontrol agent that is effective on the plant, so use has to be made of herbicides and manual labor to control these plants. Landowners can control torch cactus with herbicide, but the plants have to be damaged for the herbicide to have an effect, because by spraying the outside, just spraying on the outside of the plant doesn't work due to a waxy layer that the plant has on the outside of its cladodes. Um, Damage can be done with a cop mess or a blade or something, or even just a stick. It just needs to be damaged so that the herbicide can penetrate the stems. Jointed cactus invasions, also widespread in the Eastern Cape and particularly on game ranches and livestock farms. Um, Biocontrol is effective on this problem cactus, and the same applies here. We advocate the use of biocontrol nurseries in which to grow the control agents, and the continuous spread of infected leaves onto uninfected plants is an ongoing management practice, and it is apparently the only way in which one can control this cactus, other than the extremely expensive way of having many people picking up the plants and removing them from the veld. Here we have an example of a large patch of jointed cactus that has been completely controlled by the biocontrol agent. Very important in this case is to continuously revisit the sites where the biocontrol has been effective, and to reinfect any bits of the plant that escape biocontrol, and the follow-up, in other words, is critical. Many of the alien plants that we remove from game ranches are alien trees, such as the poplar in this case, and in other areas, black wattle trees, which are very problematic along river courses. The restoration of arid rangeland wetlands is a particular concern of ours. One finds many examples in the arid Karoo areas of where wetlands used to occur and where they no longer occur because they have been completely drained by erosion systems. In this slide, one can see the dark organic rich soil above, which indicates where a marsh or a wetland once occurred. Our approach with the restoration of wetlands is to deal with the area, the catchment area of the wetland, and in this case, it is the catchment of the previous slide, where we simply treat the area with either erosion control fences or stone gabions, and uh, the other erosion control methods mentioned on flat sheet eroded areas, such as digging of hollows and so forth. Um, the other thing that we advocate is that the landowner reduces animal numbers, so that whatever does come up in these restoration areas doesn't simply get grazed away before it can have some form of useful effect. Here is another example of a wetland lost through overgrazing and through the formation of severe erosion gullies, which then drained the wetland. The action here, as in the last slide, would be to treat the areas above this erosion system and to try and rehydrate the site by establishing a healthy plant cover and by means of erosion control structures. Here we have an example of a completely restored wetland and a healthy drainage line, which has a good plant cover which will resist floodwaters and prevent erosion along the banks. This has been achieved by means of some erosion control work and also the sensible management of wildlife numbers on this game reserve. Here we have a peat wetland on private land in the Southern Cape, threatened by invasive alien black wattle trees. The problem is that these wattles establish in the wetland. They are very poorly rooted, and whenever there's a bit of a flood, the wattle trees are knocked over, creating a hole in the ground, and this can often result in severe head cuts, which then result in the draining of the wetland. Um, One of our concerns in this area is that these wetlands, such as this one in the Veyers River near Herbertsdale, um, are home to a number of endemic fish species, one of which has yet to be named. Um, a major way of controlling black wattle is using biocontrol. We have a gall midge, a midge that lays its eggs in the bud of the flower of the black wattle, and this causes a hard gall, which then prevents the tree from manufacturing seeds. So we see this as a holding action. Most of the black wattle trees in the area are infected in this way, and it it uh, it is valuable in that without any seed production, we don't have any new infestations of black wattle trees until such time as we can get the finances to move in and actually cut all the alien trees out of the area. In the same area, we have a problem with the invasive alien Hakea in the Langeberg Mountains, and again, use is made of biocontrol agents, which are put out to control the seeding of the Hakea trees. And this is an ongoing program, and together with selective removal by hand, um, the denser infestations are infected and left up to the biocontrol. This is the Marmora cork oak forest in Morocco in the Mediterranean northern part of Africa. As you can see, the habitat consists mostly of large trees and shrubs and a ground cover of dwarf palms, smaller shrubs and grasses. The cork oak forest on this hunting farm has been largely destroyed because of over-harvesting of the cork bark, which results in the attack of the cork oak trees by insects and fungi, and also general overgrazing of the area by livestock and game. As part of the general management of the hunting farm, game birds were fed with automatic and open game bird feeders, and the result of this was that the European rabbit population exploded and basically consumed everything on the farm. Um, they they ate most of the grass and also the low-hanging branches of trees and shrubs as well. The reserve is also used for the breeding of rare Saharan wildlife species like the addaxed antelope shown here and the Dama gazelle also shown. Other species include other members of the Gemsbok family and also animals like the Barbary sheep. These animals were bred for hunting, and unfortunately, numbers increased to the point that severe overgrazing also occurred in the area that they occupied. A major project was launched to re-establish the cork oak forest where it had been destroyed, and a nursery was set up for most of the woody species that occur on the hunting farm. These plants, when strong enough, were planted out in plastic tubes in their thousands, and they were watered until they were strong enough to be left without watering. Here we can see the rehabilitated part of the cork oak forest. The smaller trees are the trees that were planted, and the ground covers, including the dwarf palms, were also re-established in the area. This is the Hunter's Moon Game Reserve in the Northern Cape along the Orange River. Soon after it was purchased, and a number of photographs were used to compare veld conditions from year to year. This is an area that was severely overgrazed by the previous landowners with domestic livestock. This is roughly the same area as in the previous view after 17 years of careful veld management and fortunately some reasonably good rains. This despite the fact that the reserve was stocked with large game for hunting, and many animals were removed every year
to keep the numbers of animals on the land more or less in track with conditions in the veld. The grasses that you see are mostly perennial grasses, which basically took a full 17 years to develop. Originally, it was just the white grasses like Aristida and very little perennial grass. But perennial grasses basically started moving out of the hills and onto the plains. This is the Pinars River near Graafrenet, an area where some soil erosion control was done. And the method used here to control the erosion was basically soil erosion control fences, which were installed to slow down the speed of runoff water and to trap organic material. This is a view of exactly the same area in the Pinars River near Graafrenet, only 1 year after treatment and with some very good rains having fallen. As you can see, there is a complete grass cover in an area that was formerly almost completely devoid of any kind of ground cover. Commercial game ranchers are often frequently accused of caring only about profit and very little for the land. The examples that I've shown you tell something of a different story. Game ranchers are just as concerned about the condition of the resources on their farms as livestock farmers are. And there are probably as many poor quality game farmers as there are poor quality livestock farmers. Thank you. That is it.
Good day, everybody. My name is Nkululeko Nyangiwe. I'm working for the Department of Rural Development and Agrarian Reform at DUNI as animal researcher and as well as an acting director for the section Animal and Pasture Science. My topic today is about population dynamics of ticks on and off bovine hosts grazing under different agroecological zones in the Eastern Cape Province. Basically, ticks belong to the phylum Arthropoda and the order Acarina, and there are two families of ticks. It's the family Ixotidae and the family Acastidae. The family Ixotidae are basically such kind of ticks that infest animals like cattle, while the other family, it's just involving ticks that is affecting the fowls, like mainly the monogastric animals. What limits a tick population? Tick population dynamics are influenced by abiotic factors such as temperature, rainfall, and humidity. These factors determine the vegetation type and they affect the survival and questing activity of ticks. Ticks depend on vertebrate hosts for their blood meals, meaning that for their survival, they need the availability of animals in order to survive, as well as what is important is the temperature and the humidity that has been actually set and before earlier on. Adequate vegetation cover can provide a suitable environment for tick survival. As a result, tick abundance may vary between different vegetation types. This is actually the life cycle of one host tick with the example of Rhipcephalus microplus, that is an Asiatic blue tick. Under this life cycle, all stages of ticks, that is the larvae, the nymph, and adult, they remain under the single host until such time that the engorged female drops off and lay eggs on the ground, where it actually taking about 2 months for hatching the eggs. And this kind of life cycle spend less time in the environment, as you have seen there that all the instars, the larvae, the nymph, and actually the adults, they remain on that single host. And that is not the case for multi-host ticks. Here I'm having the example for 3 host ticks. I left purposely the 2 host ticks because their life cycle is more similar, because under the 2 host ticks life cycle, the ticks they are using first host and second host. This one is including all the hosts, that is the first, second, and third one. But under this life cycle, you will find that the ticks, they spend more time in the environment. And what differs from the first life cycle is that the immatures, that is the larvae and the nymph, they attach the animal and feed, and they drop off to the ground where they molt, meaning that the molting is happening on the ground, unlike where it was happening in the on the animal. So this is a typical kind of a life cycle, and it's a longer one because it takes about 3 years to be completed. Meanwhile, the first one is taking about 21 days. About 21 days. So this is it's taking very long, and the control strategies for these ticks are one life or one host ticks and the 3 host ticks and 2 host ticks. It differs. That's a good thing that someone needs to know. Season as a limitation. You will see that the adult from animals, they normally become more abundant during the hot, wet season. You can see there from November up to March or February. Meanwhile, the immature stages, they are available, but at lower numbers during winter. What you can also see is that as much as you will get the larvae and the nymph during hot, wet, probably at higher numbers, but during winter, their numbers, they become lesser and lesser. This is also due to some of ticks, they go overwintering, where they are hatching and then taking some 2 months to 3 months to come up. That's why the numbers are normally becoming lower during winter compared to active season like hot, wet season. The objective of this study was to determine the ecological preferences and seasonal dynamics of free-living and parasitic ticks from cattle and on vegetation in the Eastern Cape province. Coming to materials and methods, we were using 3 study sites, that is Adelaide Research Station, Forte University Farm, and Bathurst Research Station. All these stations differ in terms of vegetation type. In terms of sampling technique, we employed 2 sampling technique where there was a removal of ticks from the cattle using forceps, where we use 10 animals at each locality, and again from the same locality we are collecting ticks, that is the free-living ticks, from the vegetation. We were using 6 replicated drags. You can see there the operator is dragging over the vegetation using those the drag apparatus with 10 flannel strips. After all collections that were done, we were taking the ticks and then put or place them or store them in 70% ethanol. And in terms of data, the data was analyzed using SARS-CoV-3, but because of the data was not normally distributed, then the tick count data were log transformed in order to achieve the normality and stabilize the variances before applying ANOVA. The effect of vegetation and season on tick counts was also determined using the generalized linear model procedures. The result from this study was actually published in Experimental and Applied Acarology. This is a work which is been done by one of my PhD student, Mr. Mandla Yawa. These are the results. We recovered 10 tick species from the 3 sites, and then you will note that in order of abundance, the blue ticks, which is the Rhepcephalus bophilus ticulatus, was found at higher numbers, followed by Rhepcephalus evades, that is the red-legged tick, followed by Embleoma hebrium, that is the South African bone tick, which is the vector of heart water disease. You'll also notice that the larvae for the Embleoma hebrium was not found at higher. There was not found at higher numbers here, simply because of the Embleoma hebrium is a 3-host tick, meaning that in most cases they are using different hosts. So at the time when you are doing the tracking over the vegetation, you may not find them. And if you look from under the larvae comes, you find that there are those that are 11, 10, 5, 7, all those that are in lower numbers. This is an indication that they were the ticks that are belonging to 3-host ticks. Because you'll find from the 2-host ticks, the Rhepcephalus evades is 487. It's becoming higher, but for the 1-host ticks, because of they are in large numbers on the vegetation, those one, because this either they are on animal or on the vegetation. So it's just the indication that those one are found in higher numbers. And also it's important that these are the major ones that are found in Eastern Cape, and they are the ticks of veterinary importance in the Eastern Cape, including all other provinces. But here in the Eastern Cape, we've got a lot of them in terms of tick-borne diseases as the vectors. Coming to seasonal variation across the vegetation types, you will find that significantly higher numbers were actually recovered during summer under all of these vegetation types. Look at the Embleoma hebrium. It was found higher during summer. Also from the BTG, Bischoff-Thornfeld, and the KT, a COVID ticket, as well as the PT, PT. Then, also interesting, it was to note that the Hyaloma rufipes was not actually recovered from the COVID ticket. And this is just showing the ecological preferences of these ticks that one is good to note for the control strategies. And then also, if you look from the other one that is Rhepcephalus ticulatus, those are the major ticks that are occurring in the Eastern Cape. But one can see that the season, in particular the summer, plays a big role for these tick species. Coming to discussion, the most abundant tick species, as I indicated, was Rhepcephalus ticulatus, that is the blue tick. where it was actually found more in Bishoptonveld, but it was found less in Bedford dry grassland. And then the findings have been noted to support the other surveys. And also a large number of adult Arab Keflas visits was observed in Bishoptonveld during summer season. This is a red-legged tick, and then is one of the most widespread tick in South Africa. So also these results also are in agreement with other results or other surveys that have been done, as indicated as well that no Hyalomarophypes was collected in the COVID thicket vegetation. In this study, tick population was high during the summer season, and the Amblyoma hybrium, which is a South African born tick, and the causative organism for hot water, and as well as the Rhepkephlas decoratus, which is the African blue tick, causing the red water, were the most prevalent ticks on cattle during summer. And actually, these are the ticks of great veterinary importance in South Africa. In particular, if you talk about the Amblyoma hybrium, and then you've noticed that it was more on a COVID thicket, which is the Bethes, and the Bethes is located along the coast. So that's also giving you the impression of why we are always having a high incidence of hot water along the coast, because this tick is a tick that is usually associated with coastal pockets prevalences. Seasonal variation and agroecological difference has influence on the abundance of ticks, and from this study, we did not actually collect or get the Rhepkephlas microplus, which is an Asiatic blue tick. That is a one-host tick like a Rhepkephlas decoratus. So this one is a very tick that is widespread in South Africa. So the manner that we didn't get from the study, it warrants a further investigation. And as such, we developed another project on a longitudinal study to investigate the factors that at play as to why this kind of ticks is not actually being collected from the sites that have been surveyed to. And then we are hoping that we will try to get some results. The following are acknowledged for their support and funding. We thank NRF for the funding, and also the department and the colleagues. Thank you, ladies and gentlemen.
Good day, GSSA colleagues. Today I'm going to speak about the development of a landscape level elephant management plan framework for the Great Limpopo Transfrontier Park and Conservation Area, GLTFCA. I'd like to acknowledge my co-workers, Greg Martindale, Nissia Giver, David Cumming, Jeremy Anderson and Graham Wolfhard. The purpose of this elephant management plan framework is to assess the role that elephants play as key drivers of landscape change, to examine the economic, social and aesthetic value within the GLTFCA, to evaluate the threats that elephants face, illegal wildlife trade, habitat destruction, human-wildlife conflict and unethical hunting practices. We look at elephant movement and the establishment of wildlife dispersal corridors between protected areas and the potential human-wildlife conflict that may occur because of these corridors. Just to give you an idea of the extent of the GLTFCA, starting in the west, the associated private nature reserves in Kruger National Park in South Africa, Limpopo, Benin and Zinov National Parks in Mozambique, and Gonarazor National Park in Zimbabwe. The purple shaded areas are the potential corridors for movement between these protected areas. Terms of reference is to set up a database of existing elephant management related initiatives within the GLTFCA, which include the following key points: ecological baseline, stakeholder base, policy, legal and institutional context, land and natural resource access and use, and the role of elephants for society, mainstreaming the benefits of elephants for social development. We look at the goals of national policies as well as global sustainable development goals. We aim to set up a common vision, mission and principles to guide the development of the GLTFCA landscape scale EMPF using a participatory, stakeholder-driven process. And this will be finally approved by the Joint Management Board and ministerial committees of the 3 countries. So the outputs and progress that we put together in the Inception report, a standalone wildlife translocation policy, situation analysis report providing a comprehensive context for elephant conservation and management, stakeholder engagement and communication strategy. Key findings of the situation analysis will be taken to stakeholders, and then an initiation of the stakeholder engagement process will occur. Following that, there will be a draft GLTFCA EMPF, and finally the final GLTFCA Elephant Management Plan framework, following a review of that draft and further stakeholder engagement, and there will be a stakeholder participation report. Wildlife translocation. In terms of the wildlife translocation, the scope is actually a full spectrum of conservation translocations within the GLTFCA aiming at getting a common policy for wildlife translocation. This includes definitions and classifications, the viability of translocations, the planning of translocations, the feasibility and design of translocation. The risks involved in wildlife translocation, the implementation of the said translocation, monitoring and management pre and post release, and even up to the adaptive management phase, and dissemination of information, maximum amount of information and timely distribution. The situation analysis, looking at elephants, which are complex animals. As Topsoil 1607 said, there is not any creature so capable of understanding as an elephant. They are apt to learn, remember, meditate and conceive such things as a man can hardly perform. So just looking at the GLTFCA in terms of size, although the boundary is not formally defined, it's approximately 52,900 square kilometers, or 5,290,000 hectares. Generally low altitude areas from about 70 meters to 400 meters above sea level. High temperatures, low and variable rainfall, frequent drought and occasional floods, and marked wet and dry cycles with a rainfall of between 400 and 700 millimeters. In terms of drainage, 3 large rivers drain the Zimbabwean portion, 9 the South African portion, 5 of which flow in Mozambique, and there is a delta type system in Benin. In terms of artificial water provision, we're going to look at the lessons learned in South Africa and the risk of applying artificial water further to the east could cause the loss of animals like reedbuck and oribi, and preclude the reintroduction of roan, sable and tsessebe, which are all poor competitors. Situation analysis. Africa-wide, there are approximately 415,000 elephants in Africa, according to the IUCN 2016 report. Of that, 293,000 odd are found in Southern Africa, making up 42% of the total. And the Southern African sub-region consists of Angola, Botswana, Namibia, Zambia, Zimbabwe, South Africa and Mozambique. So let's look at each country. In Zimbabwe, the current estimate of elephants is 80,000, which is the second largest in Africa after Botswana, and they are found in 4 discrete populations. Despite attempts to halve the number, with a culling of 60,000 elephants between 1965 and 1990, and high levels of poaching between 2001 and 2014, these numbers are still substantial. In the GLTFCA, there are approximately 13 to 14,000 elephant, growing at a rate of around 5%. The density of elephants is 1.5 elephants per square kilometer, with a range of 0.33 to 2.12. In Mozambique, in 1999, there were an estimated 18,000 elephants, which rose to 21,500 in 2003, but heavy poaching between 2009 and 2014 resulted in a 48% decline to around about 10,500. Grossman in 2015 in fact states that Mozambique's elephants are under imminent danger of disappearing from large tracts of the Mozambique range within the next few years. The GLTFCA in Mozambique, Limpopo, Benin and Zinov national parks have got relatively low elephant numbers, the highest being in Limpopo with about 1,081. And the total elephant number in Mozambique is currently at around about 10,800 animals. In South Africa, up to 1910, due to human settlement and the ivory trade, there were 4 remnant populations. Due to consistent conservation efforts, there are elephant in 7 of the 9 provinces currently. Celia et al. 2016 estimate the South African population to be around about 26,800, which is the 3rd largest in Africa. The current estimate in South Africa is between 35 and 36,000 elephant. The GLTFCA area of South Africa between 1967 and 1997, 14,600 odd elephant were culled, and between 1997 and 2003, 2,047 elephant were translocated. In the private protected areas, most of the off-takes is through hunting, with 407 animals removed in the past 11 years. So the GLTFCA's population in South Africa is around about 32,500 at a density of 1.05 elephants per square kilometre and a range of 0.42 and 2.37 elephants per square kilometre. Elephant and people corridors within the GLTFCA. Ecological corridors are supported both nationally, regionally and internationally through legislation. It is essential to maintain connectivity at all levels of biological organization. Human-dominated landscapes such as the LNP buffer zone, land use by humans can result in habitat loss and fragmentation, blocking migration routes to other protected areas and giving rise to human-wildlife conflict. So who are the key stakeholders? Let's start with the secondary stakeholders, which is the general public, tourists and interest groups, and their issues are sustainable resource use, human rights and animal welfare mostly. The national decision makers, that's national government ministries, directorates and departments, and their issues are national elephant management strategies and policies, legislative and international obligations. Strategic partners are conservation authorities and NGO partners, and they're looking at protected area and species management, expansion, establishment of wildlife corridors, translocations and human-wildlife conflict. And then the primary stakeholders, traditional leaders, community forums, community members, private landowners and concessionaires, and their issues are largely wildlife, human-wildlife conflict, tourism and hunting. So what are the challenges with these corridors? If we look at the Limpopo River flowing into in Mozambique, you see a lot of human settlements, and there were 6 identified potential corridors, 3 of which were discarded, decided they was not feasible. Those are in red, underlined in red in the figure, and these are now of low conservation value because of the wide distribution of human settlements. The stakeholder engagement. We need to understand stakeholder perceptions, challenges and opportunities associated with elephant conservation and management. We need to develop a common vision, mission, principles and objectives for animal management. Inclusive and participatory stakeholder engagement process is critical. So we've set up a series of one-on-one engagements with smaller focus groups, a workshop in each of the GLTFCA partner countries, a final meeting of task team members and key stakeholders, and that will be a joint consideration involving all 3 countries. Project outputs and progress. The inception report is complete. The standalone wildlife translocation policy is complete. The situation analysis report providing a comprehensive context for elephant conservation management of the GLTFCA is in its final draft. The stakeholder engagement and communication strategy has been initiated. The key findings of the situation analysis is taken to the stakeholders and the stakeholder engagement process initiated. The draft GLTFCA MPF will be completed in September 2021, and the final Elephant Management Plan framework, which will take into account a review of the draft and further stakeholder engagement, will be completed by November 2021. And a standalone stakeholder participation report is also aimed at for end of November 2021. I'd just like to thank the following people for their funding and also assistance with the presentation that I've just given. Thank you.